All right, geometry. You guys, you made it. This is the last standard for geometry. And it is super short and sweet, and I hope you find it easy and enjoy it like I do. Okay, standard 19 is understanding the standard form of circles. So being able to graph circles if you're given the equation, being able to write an equation. We do have to recall the distance formula, but I think once we do a little refresher on it, when we get to one of those problems, you'll be fine. So let's go over the standard scale. Okay, so 4 key parts. We want you to be able to identify the center and radius of a circle and graph it. Okay, once you know the center and the radius, I think you're all capable of that. Something to just make a little note of is you will label the center and the radius on your graph. Okay, required, yes. Okay, write the equation of a circle given its center and radius. Okay, then we want you to be able to write the equation of a circle given its center and a point the circle passes through. That's your distance formula. Okay, and the last one, we want you to be able to write the equation of a circle given the endpoints of its diameter. Okay, which means you're going to have to find the midpoint and the distance. Okay, so you can do this, and if you can do those 4 things, guess what level you're at? You're at a level 4 if you can do all 4. Okay, so what do you think the rest of them are? If you can do one of them, you're at a 1. 2, you're at a 2. 3, you're at a 3. And if you can do all 4 successfully, you've earned yourself a 4 for standard 19. Okay, so we have 1 in-class day for this, 1 homework assignment, and then the review. That's it. Okay, so the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Okay, where blank is the blank of the circle and blank is the blank. Okay, so where hk is the center of the circle, which means what's left in the equation, because you know x and y stays in the equation, is the r. And what's the r stand for, we all know in a circle, is the radius. Okay, now here's what I want to point out to you. Notice for the coordinate, hk is positive. Okay, but in the equation, it's subtraction. So when you have an equation, you guys, it's always going to look opposite. Okay, if h and k are positive, okay, you're actually going to move, x would move to the right, and y would move up. Okay, so when h and k are both 0, where's the graphed circle centered at? Where's the center of the circle? If h and k are both 0, okay, your equation would look like this then, right? Equals r squared. Okay, so the center would be at 0, 0. Center, label it with a C, is at 0, 0. Okay, now let's look at when h is a positive number. Okay, if h is positive, then what direction does the graph move? To the right. Okay, if h is positive, h is the x value. Okay, so positive numbers on the x-axis go to the right. Okay, and what does the equation for the circle look like if only, oh, that's your x minus h squared part, because h is positive, but the equation says x minus whatever that h value is. Okay, if y doesn't move, you would just have plus y squared equals r squared. Okay, that would be something that the equation would look like if h is positive and you didn't have a k. Okay, so now let's look at what happens if h is changed to a negative. what direction does the graph move? If h is negative, then my x values are negative when I go to the left. Okay, and here's what that looks like, you guys. The equation is x minus h squared. So if h itself is a negative h, it looks like that. So it actually makes it x plus h squared. Okay. So the equation for that, I already started doing that up above. Okay, if I didn't have a k, it would look like that. So this is what I was saying initially, because the equation is x minus h squared and y minus k squared, it's always going to look opposite. Okay? And then we're going to look at what happens when we change k. So k is dealing with our y coordinate. Okay, think about your graph. Your y-axis moves up and down, right? So what direction does the graph circle move when k is positive? The graph is going to move up. Right? And what's it look like if k is negative? It's going to go down. Okay. It didn't ask, but we might as well write the equation. If I don't have a change in my h, okay, if the graph is moving up, my y will be y minus k squared equals r squared. Okay. And again, if it moves down, that means k is negative. So if I have y minus a negative k, what happens there makes those positive, right? So if my h didn't move, my x value didn't move, I would have y plus k squared equals r squared. Again, looks opposite. Okay, so let's go do some graphs. Okay, here's the equation. Flat out give it to you. Okay, straight up. So, where's the center of the circle? Graph the circle given by the equation below. List the center and radius before graphing. So I want you to identify the center and the radius. We're actually going to put it on the graph, but the center looks opposite because my h is actually a positive 1, right? So it's 1 and negative 3. And my radius, remember that's r squared, so my radius is 2, right? Because r squared equals 4. So to get r, you would square root it, and I can't have a negative radius on a circle, of course. So I go to 1, negative 3. Plot that point, the center, 1, negative 3. Okay, and here's how we can get a decent circle. Radius is 2, so go 2 up, down, left, and right. Right? We got 4 points on our circle. We're going to circle it up the best we can. Just don't let it look like a square or something. Draw your radius to a point that's not one of the 4 you plotted, and put your radius on there, 2. Okay, let's zoom in so we make sure everybody can see that. Center and radius are labeled. Okay, I don't want it written out here and draw an arrow. Put it on your circle. Okay, not asking that much work. You can do it. Okay, next one. Again, you think you got it after doing that one? Go ahead, pause it, and give it a try. Center looks opposite, so it's positive 2, negative 1, and my radius is 4. And are they all going to fall exactly nice? The answer is no. So 2, negative 1 is my center. My radius is 4, so I'm going to go out 4 each direction. Okay. And then I'm going to sketch the best circle I can. As long as it doesn't look like a square, I know sometimes it can look like a little bit more like an oval. I don't have the best circles, but there definitely aren't corners on there. That's what would make it more of a quadrilateral of some sort, right? Make sure it's rounded. Okay. Go ahead and turn the page for the last 6 examples of the year for geometry. Okay. So, use the information provided to write the equation of a circle that fits the criteria given. Use a graph to help you if necessary. So a graph is not required. If you use one, that's fine. Okay, but you don't have to label it because I'm not grading the graph in this case. Okay, so I'm given my center. So x minus 0 squared plus y minus negative 6 squared equals 5 squared. Okay, do you have to write that all out before you simplify it? No. If you can see right away, the equation is x squared plus y plus 6 because it's always looking opposite. And then 5 squared is 25. That's fine. Go straight to that. that's it. Okay? We're going to build on it a little bit because we're going to have to get to where eventually you're going to have to find midpoint and distance. Okay? So, for example, right here, the ends of the diameter are 9, 4, and negative 1, 4. So I'm going to just throw these on here. So 9, 4, and negative 1, 4. So the diameter is actually horizontal here. So if you look, you can count. Okay, here from the axis over to 9, so they're 10 apart. You can just count, right? Because it's horizontal. Oops, I guess you're not on the screen, sorry. They're horizontal, right? So you can just count that they're 10 apart. So where would the center be? In the middle at 5 each way, right? So my center would be at 4, 4. And what's my radius? Well, again, you can just count. From 4 to 9, I went over 5. Okay, so x minus 4 squared plus y minus 4 squared equals 25. Okay, so when the diameter endpoints are horizontal or vertical, right, you can just count. It's a little bit easier. You don't have to use the distance formula or the midpoint formula. Okay, and then we do. Okay, so number 5, endpoints are at 6, 3. Negative 6, negative 7. So we need to find the midpoint. You can't eyeball it. You can actually calculate to find the midpoint. We did this way back first semester. Okay, you do this by adding your x's and divide by 2. And then add your y's and divide by 2. Okay, so it's kind of like this: x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, this is for the midpoint that will get you the center. Okay, well that's just 0. That's negative 4 divided by 2 is negative 2. 0, negative 2. Okay, so that's one way. That's what you should do to get your center. Okay, now we need to get our radius. Okay, so you could do this one of two ways. You can find the distance between the endpoints of the diameter and then divide by 2. Or once you've got your center, just find from the center to either endpoint. Okay, so your distance formula, remember, is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so I'm going to use my center and one of these points. It doesn't matter. I'm going to use the positive one in this case. Doesn't matter. Okay, so it's the square root of 0 minus 6 squared plus negative 2 minus 3 squared. Okay, remember that anything in parentheses being negative, when you square it, it makes it positive. So none of your numbers, when you calculate them under the square root, should be negative. Okay, so the square root of 61 is the distance from my center here. So this is my radius, and I almost always put that it's my radius. So my radius is the square root of 61. But what's my equation say I need for my radius? I need to square it, so I can square both sides. And what's the square root of something squared? Just itself. So the radius squared is just 61. And here's my center. So my equation is now going to be x squared. You can put x minus 0, that's fine. Plus y plus 2 squared equals 61. Okay, if you should forget the distance formula, do you see another way that you could actually calculate that? Especially being on a coordinate plane. If you look at this distance, couldn't you just make a right triangle here and find the hypotenuse of that right triangle, right? You can count over and left or right or up or down or whatever, okay? That's what the distance formula is. Okay, that's all the distance formula is finding the hypotenuse just with all the work done, okay? Just plugging in the numbers then. Okay, this one actually gives me the center, so I can write part of my equation. X plus 2 squared looks opposite, remember, plus y minus 5 squared equals, so what I need to find here is my radius. So if I'm at -2, +5, I'm going to 0, 3. So again, I got to go to the distance formula from my center to a point that is on the circle, okay, which is 3, 0. I'm going to do -2 minus 3 squared plus 5 minus 0 squared. That gives me 25 plus 25. So the square root of 50 is my radius. So my radius squared is just going to be 50. Okay. Last two. Again, you feel like if you haven't tried one yet on your own, you guys, pause it and do it. Okay? It'll give you more confidence that you can do this. Okay, so I've got part of my equation is x minus 6 squared plus y plus 3 squared. I've got to find my radius, right? So square root of, and I always just mark it r equals so I remember it's the distance formula, but what I'm specifically finding in this unit is the radius with it. So 6 minus -3 squared plus -3 minus 9 squared. Minus a negative turns to positive, so that's 9 squared or 81. Plus, that'd be -12 squared is a positive 144. Add those together, and I get the square root of 225. Don't actually take the square root of it, okay? Because that's my radius. Remember, I have to square both of them to plug it into my formula, which gives me exactly 225 then. And you're done. And the last one, we have to find the center, okay, and the radius. We got to find both. All right, so here we go. So you can plot the points to make sure. I think you'll be able to tell by the coordinates that it's not vertical or horizontal, but plot it just to help you. Okay, that helps you give you that visual. Do it. Okay, so I need to find the middle of those. Again, I can't eyeball it. So I've got to find the midpoint in order to find the center. Okay, so my midpoint, I add my x's, divide by 2. I add my y's, divide by 2. So this is -1/2 and 0. Does that look about right? I'd say pretty close, yeah. Okay, so that's my center. And now I have to find my radius. Okay, so my radius is the square root of -1/2 minus -3 squared plus 0 minus -4 squared. Okay, so -1/2 minus a negative makes that positive, so it's really 2.5 squared. Okay, and minus a negative here makes that +4 squared. Doesn't matter because it was squaring it. But again, I end up with square root of 22.25. I have that right. -1/2 minus -3. Yep. Okay. So normally we would not allow decimals to stay in our square roots, but remember, what are we doing with this? We're squaring it both so we are squared so that we can write the equation. So it's totally fine. Okay, so we've got our center now and our radius, so I can write my equation. So x plus 1/2 squared plus y squared. You don't have to have parentheses, I just started to put it before I realized it was 0, equals 22.25. There you go. And that finishes, if you can believe it, the last in-class lesson and the last unit standard for all of geometry. You guys have knocked it out of the park. Y'all made it this far, so way to go. Okay, you can now do homework 82 to wrap up Unit 19.